In this lesson, we're going to answer the question, how do I use tables, diagrams, graphs, and equations to represent quantities that vary together? And we're going to be working on this essential question for a little while. Let's take a look at workbook page 203. Quantities that vary together. Well, what does that mean? Let's take a look at this example. If you buy potato salad at a deli, your cost is related to the amount that you buy. Obviously, the more you buy, the greater your cost. So that means the amount of potato salad and the cost is going to vary together, meaning as the amount of potato salad changes, so does the cost. So one thing affects the other. One quantity changes, it's going to change the quantity of the other item. In this case, potato salad to the price. We can use these variables to represent this relationship. We can use P to represent the number of pounds of potato salad a person buys, and we can let C be the cost in dollars for, that number of pounds. So we've got two different variables because we're talking about two different quantities, pounds of potato salad and cost in dollars. Each variable above includes a unit of measure. This is so very important. Please remember this. Each variable includes a unit of measure. The variable P represents the number of pounds of potato salad, and the variable C represents the cost in dollars. It's always important that you include that unit of measure, especially like for P, for pounds. When I talk about the amount of potato salad, am I talking about quarts of potato salad? Am I talking about, ounces of potato salad? I need to know exactly what that quantity is, so I need that variable to include a unit of measure. A double number line can be used to illustrate the relationship P and C share. A double number line is a pair of number lines that show how two variables relate to each other. The double number line below shows how P and C vary together. So you can see it's just like two different number lines, one on top of the other. The one on the top is for C, the cost in dollars. And the one on the bottom is for P, the pounds or the weight in pounds of your potato salad. And you can see that the dashes here show the relationship between the two. So if you have 0 pounds of potato salad, obviously you're going to be spending $0. It's not going to cost you anything. But now let's say you buy a 1/4 pound of potato salad. Well, now that's going to cost you $1. If you buy 1/2 pound, now you're up to $2. If you buy 3/4 of a pound, now you're up to $3. So you can see how one affects the other, and it's illustrated on this double number line. Now, looking at page 204, motor vehicles require fuel. Obviously, you need gas to, get your car to go. Suppose a gasoline pump dispenses gasoline into the fuel tank of a car at a rate of 1 pint per second. So we've got a unit rate here, 1 pint per second, 1 pint in 1 second. There are two quantities in this situation. The two quantities vary together. As one changes, the other one's going to change too. Well, what are these two quantities? Well, the two quantities are, first, the amount, or volume, I guess you could say volume, the amount or volume of gasoline or of gas. That's the first one. The second one is, the time, I guess, the seconds, the elapsed time, which is in seconds, and we're going to get into those units now. So for number 5, what units could you use for these two quantities? Remember we said we need to have units of measure. So if I'm talking about the first one, the amount or volume of gas, well, how much gas? How do I measure the gas? In this case, I'm going to measure the gas as pints of gas, and then for the time, I'm going to do seconds for the time. So those are my two units, pints and seconds. And now let's actually use some variables for them. A lot of time you'll see variables that kind of go along with the problem. Since we're talking about pints, maybe I'll use P to be my variable there. Let P represent the pints of gasoline. And then since we're talking about time, I guess I could use S for seconds. I think I might do T for time though. So T represents the elapsed time in seconds. Okay? And you don't have to use P and T, your choice. You can come up with your own variable if you want. Now we're going to label our double number line to show how the quantities vary together. So I'm going to put the time for the second number line, and I'm going to put the pints for the first number line. Because as the time increases, the more pints of gasoline are going to be, flowing into the fuel tank. So let's say I'm talking about, let's just say 0 seconds. It's always good to start with 0. If I'm at 0 seconds, obviously I have 0 pints of gasoline. Well, what if I have 1 second? Well, remember we said that the gas was flowing into the fuel tank 1 pint per second. So that means it's going to be 1 pint in 1 second. If I have 2 seconds, now I'm up to 2 pints. 3 seconds, now I'm up to 3 pints. 4 seconds, obviously 4 pints. 5 seconds is now 5 pints, and so on and so forth. Now let's look at, on page 205, Mr. Preto makes his own biodiesel fuel by mixing vegetable oil and ethanol in the ratio of 5 liters of vegetable oil to 1 liter of ethanol. So 5 liters of vegetable oil for every 1 liter of ethanol. That's the mixture that we need for his fuel. The amount of vegetable oil and ethanol vary together. Obviously, if you're making a lot of gas, biodiesel fuel, the more ethanol you put in, the more vegetable oil you're going to need, because you got to keep that ratio of vegetable oil to ethanol the same. So for number 8, define the variable V for the amount of vegetable oil, and define the variable E for the amount of ethanol in Mr. Preto's biodiesel fuel mixture. So let's see, they want V. I'm guessing that's for the vegetable oil. Remember, we need to include units. In this case, my unit is going to be liters. So V is going to be the liters of vegetable oil. And then E, well, guess what? E is also liters, but it's liters of the ethanol. So I included my units of measure for both of them. Both of them have units of measure using liters. Now for number 9, we're going to complete a table and discuss how that table and our diagram and all the equations, how they all relate to our problem with Mr. Preto's fuel. Remember, 5 liters of vegetable oil to 1 liter of ethanol. So let's say I've got 5 liters of vegetable oil, 5 liters of vegetable oil to 1 liter of ethanol. Well, now if I have 10 liters of vegetable oil, I would need 2 liters of ethanol, right? Because I'm doubling it. If I want to put in 3 liters of ethanol, I'd have to put in 15 liters of vegetable oil. And of course, 4 liters of ethanol, now I'm up to 20. Basically, you can see each time here, I'm increasing it by 1. And over here, each time here, I'm increasing it by 5. So this side I'm adding 1, this side I'm adding 5. Or, think of it this way. Let me get a different color here so you can see this. 1 times 5 gives you 5. 2 times 5 gives you 10. 3 times 5 gives you 15. Do you see what's happening here? You've got a unit rate that is repeating, a constant rate. It was 5 liters of vegetable oil to every 1 liter of ethanol. So 5 liters of vegetable oil per liter of ethanol. Now let's see what that looks like in our diagram. Here you can see how the vegetable oil, there's actually 5 boxes of it. That represents 5 V-liters of vegetable oil. And for ethanol, we have just 1 liter. So for every 5 liters of vegetable oil, we have 1 liter of ethanol. We could continue this diagram if we wanted. Maybe if I wanted to have 10 liters of ethanol, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I made it work. So I've got 10 liters of vegetable oil, which means I would now need 2 liters of ethanol. Now look at the equations. There's actually 4 different equations that you can use to represent this situation. Notice the first 2 equations start with V. V equals, in this case, E plus E plus E plus E plus E, or 5E. V, remember, was the number of liters of vegetable oil. E, if you remember, was the ethanol. Meaning, if you want to know how much vegetable oil you need, it's basically 5 times the amount of ethanol. Remember over here we were multiplying by 5. 4 times 5 is 20, 3 times 5 is 15, 2 times 5 is 10, 1 times 5 is 5. The amount of vegetable oil is going to be 5 times the amount of ethanol. So what if I had, let's see, what if I decided I was going to put in 10 liters of ethanol? Well, then I would have to do 5 times 10, and the vegetable oil would be 50. Does that make sense? The E represents the number of liters of ethanol. So if I multiply that by 5, I'll know how much vegetable oil that would be. And you can also see it here with the addition. Instead of doing 5 times E, you can just do your E plus E plus E plus E plus E, because that's the same as 5 times E, because it's repeated addition. Now the other equations here, you'll see start with E now. Now we're talking about the ethanol. What if I want to know how much ethanol I need? Well, if I want to know how much ethanol I need, I'm going to have to figure out how much vegetable oil is in there, and I'm going to divide it by 5. Think of it this way. What if I continued this table and I put 50 here for the vegetable oil? Well, I'd have to think, okay, what number times 5 gives me 50? Or I can work backwards. I can do the number or the liters of vegetable oil divided by 5. 50 divided by 5 is 10. Or another way to look at it is to use your fraction, 1/5 times V, because you're saying that the ethanol is basically 1/5 of V. Remember, 1/5 of V means 1/5 times V. So what if I said, okay, I've got 60 liters of vegetable oil? Well, I could do 1/5 times 60 to figure out how much ethanol that would be. I can cancel if I wanted. Let's see, I think I'm going to cancel, and that's going to give me 12. So you could just divide by 5 and work backwards, or think, oh, okay, the amount of ethanol is 1/5, right? 1 of the 5, 1/5 of the vegetable oil. Now we're going to write equations for a relationship. An electronics store offers a payment plan for purchases over $200. Customers can make a $100 down payment and then pay the remainder in 3 equal payments. Let T be the total amount of a customer's purchase in dollars. P is going to be the amount of each of the 3 equal payments in dollars. So now we're going to use T and P. T for the total amount, P for the payments. So what we're going to do and by the way, this is page 206, what we're going to do here is we're going to start by filling in the table, and we're going to then use our diagram in our table to help us write equations. I think the table really helps with the equations though, but you can use the diagram if you prefer. Alright, so let's see. What if my payment is $150? So let's see. Let me get my pen going. We've got a $100 down payment, right? Down payment is just the amount of money you put down, and then you can make the rest, in other payments later. So we've got this $100 down payment, and then we've got these 3 equal payments. In this case, the 3 equal payments are $150. So what I would have to do is I'd have to figure out what is my total price, or the total cost of whatever it is that this person's buying. So I could think, okay, $100 was put down, and then they're making 3 payments of $150. So I can just add it all up and figure out my total payment. 150 plus 150 plus 150 plus 100. And let's see, that's going to be 550. Now look at this next one. Now I've got $1,000. That's my total payment, $1,000. So remember, if I have $1,000, I might start by taking out the $100 down payment, and that would be $900. And then I'm going to split that up into 3 equal payments, so 900 divided by 3 is going to be 300. In this one here, it looks like my payment is $250. So remember, 100 was the down payment, and then we have 250 plus another 250 plus another 250 for the 3 equal payments. So let's see, if I add these up, I'm going to get 850. And then for this one, let's see, it looks like my total is 475. So if I'm starting with 475 as my total cost, I'm going to take out the $100 that I would put down, and that would give me 375. And then I'm going to have to take that 375 and break it up into 3 equal payments, so I'm going to divide by 3, and that's going to give me 125. So you can see how the table and the diagram are related. You've got your total, and to get the total, you have to do the $100 down payment and then the 3 equal payments using P. So now for the equations, let's see. T. How do I get T? What do I have to do to the P column here to get this T column? Well, think about it. In order to get T, I have to do 3 times that payment, right? Because we're doing 3 payments, 3 equal payments. So 3 times P, then plus that extra, $100 down payment. Okay? So 3P plus 100 is what's giving me T. 3 times the payment plus the $100 down payment. And then for P, now I have to think about it the other way. What do I have to do to the T column to get the P column? In this case, if you notice, what I did was I started by subtracting 100. So I did T minus 100, and then I divided it by 3 to figure out each individual payment. Something that you want to keep in mind, though, notice I did the T minus 100 first. But because of the PEMDAS, because of order of operations, if I look at this, this is telling me to do 100 divided by 3 first. And that's not the case. So I need to remember to put parentheses in. By putting parentheses in, I'm now telling everybody, hey, you have to subtract 100 first before you divide by 3. So here are the takeaways. First, the word vary. To vary means to change in value. So when we talked about quantities varying together, we're saying, hey, when one quantity increases or changes, the other one's also going to increase or change. So they vary together. And you can use tables, you can use those diagrams, you can use equations to represent quantities that vary. And things that you must remember, when labeling variables, be sure to use specific quantities and units of measure. And when writing an equation, identify what must be done to one variable in order to get the other.